are doing solving systems. I am going to just do a couple of systems problems out of practice. So I'm going to do number 1, and I'm going to do number 13 and 15 algebra. So I'm going to start with 13 and 15. So you guys should have learned that a lot of these, if you're finding out where two equations intersect, you have to know where their values are equal to each other. So you want to know where this y is equal to this y. So one of the first things that I like to do with these problems is I'm actually going to replace this y with this whole equation. Because then if I replace this y with this equation, then I'm only going to have x in my equation, and I can solve it. Okay? If we're going to assume we want to figure out where these y's are equal. If these y's are equal here, then what they're equal to is also equal to. So I'm going to just replace that, and I can do that over here. So it's going to be 2x, that's my 2x right here, minus, and then in parentheses, I'm going to put everything that my y was equal to in my first equation. So it's going to be negative x squared plus 3x plus 3 is equal to negative 1. So I just replace this y with all of that information. I distribute, so it's a negative x squared. This is going to be plus x squared minus 3x minus 3 is equal to negative 1. Okay. Now I have quadratic, which we're very familiar with at this point. Divide by like terms. X squared minus 1x minus 3 is equal to negative 1. It's quadratic, so I set it equal to 0, so I add 1 to each side. And so I have x squared minus 1x minus 2 is equal to 0. I look at this looks factorable, so I actually factor this one here, I'm running out of space. So, and so I'm looking for two numbers. I know that they multiply to be 1 times negative 2, so they multiply to be negative 2, and they add to be negative 1. I'm not going to put my calculator on this because it's very limited. 2 only has 2 factors, so that's actually going to be negative 2 times positive 1. So I go up here, I have x squared and negative 2. Negative 2x in one box and 1x in the other box. And the first thing I do is I find my greatest common factor of x squared and x is x. Greatest common factor of negative 2 and negative 2 is negative 2. X times x is x squared. X times 1 is 1x. And so my factor form is going to be x minus 2 times x plus 1 is equal to 0. And we know from solving we use zero product property. So we have either x minus 2 is equal to 0. So I add 2, so x could be equal to 2. Or x plus 1 could be minus 1 minus 1. So x could be equal to negative 1. Remember, though, that when you're trying to find your solutions, you need to both have an x value and a y value because it's a point, it's a coordinate. So what you need to do from here is if you know what your x value is, to find your y value, you can substitute it into either equation. I'm going to pick the second equation. It's just a little bit nicer. So I'm going to add 2. I'm going to replace this x with 2 minus y is equal to negative 1. That's 4 minus y is equal to negative 1. Minus 1y is equal to negative 5. I divide by negative 1, and I have y is equal to positive 5. On the other side, I do the same thing. 1 minus y is equal to negative 1. Okay, negative 2 minus y is equal to negative 1. I add 2 to each side. I have negative 1y is equal to positive 1. I divide by negative 1, divide by negative 1, and we have y is equal to negative 1. So your final answer are actually going to be these 2 points here. The points are going to be negative 1, 1, and your other point is 2, 5. Now, you also know another way. You will be given Desmos to do these problems. So in Desmos, you just put the two equations. So this is going to be negative x squared plus 3x plus 3 equals y. Gotta put the whole thing in. 2x minus y is equal to negative 1. Okay? And so you see both your equations, and if you touch this point here and this point here, you can see that those are the solutions that we had algebraically. So you choose. I'm going to think that Desmos is a little bit easier, but we'll see. Okay. So, and we'll do the rest of these problems. So we're going to do number 12. We're just going to use Desmos for 12 and 14. So for number 12, it was x squared, okay, minus 11x, so it should be 16 minus 11x, okay, and then this was plus 13 is equal to 3y, okay? And the trick to these ones right here, I did want to change this problem a little bit because the answers came out a little nasty, and I want you to practice this. So this should have been 3x instead of minus y. If you put plus y is equal to 4, it comes out a lot nicer, okay? And so what you see, this is where you kind of have to be careful. So when I say 3x plus y is equal to 4, x squared minus 11x plus 13 is equal to 3y. So, let's see. This one here. Okay, so when I hit the graphs, and the ones on the test are not unclear, it is, be careful. These points right here are just your intercepts, so it'll have points for your intercepts. So just be careful for this. Their only point of intersection is actually 1, 1. So they intersect only in one spot at 1, 1. So, okay. So for this, your answer was, so you had your quadratic, and then you had this guy, and they intersected at 1, 1, and so your answer, remember I changed that to plus, and so the answer was 1, 1. Okay. We go to the last one. 2x squared plus 5x. Okay. Plus 43 is equal to 3y, and your other equation is 2x plus y is equal to negative 1. Okay. For this, you can actually zoom out. So if you zoom out, what do you see? They don't intersect at all. So for this particular problem, there are no solutions. And if you want to see how it's done algebraically, it is done algebraically on the answer key that I posted. But for these, you had this guy here, and you had this guy here, and so this was no solutions. Okay. This next problem, this is the other problem I was going to do algebraically, so in the video. So quadratic systems, I like to do these a little bit differently. What you need to see is you can't solve this in two variables. What's kind of interesting is you can actually add equations as long as everything kind of lines up a little bit. So if I add this, I can add my x squares on one side, so that would be 2x squared. I can add this would actually are the 6x and the 28, that would be 34x. The y, this would be plus 2y. I don't have any numbers here, so I have plus 128. 4 plus 0 is 4. That's not particularly helpful sorry, this is 2y, because I still have two variables, but you can change the equations a little bit. So one of the things that you can do is you can actually multiply equations, both sides of the equation, by the same value. So if I multiply this side by -1 and this side by -1. Okay, so you can multiply each side of the equation by -1. So when I multiply each side of the top equation by -1, what I end up with is negative x squared minus 6x minus y. I don't have anything to combine with 28. This is equal to -4. Now let's try adding these equations. Positive x squared plus negative x squared is going to be 0, which is nice. It's less to worry about. Positive 28 plus negative 6 is going to be 22x. Positive y plus negative y is 0. 128 plus 0 is 128, and 0 plus -4 is -4. And now we have something very familiar. It's just a regular equation that I need to solve. So I subtract 128, I subtract 128, so I have 22x is equal to -132. I divide by 22, divide by 22, x is equal to -6. Okay? Now remember that you're looking for points, so remember you have to have an x value and a y value, okay? So remember all of these right here, they have an x value and a y value. So how do I find the y value? You can substitute it into either equation and you will get the same answer if you solve for x correctly. Something to be really careful of, this is a -6. Anytime you have a negative, and especially if you're dealing with squares, you always put your negative in parentheses. So, I guess I'm going to just go with the first equation. Always use the first, the original. So it's going to be -6 squared plus 6 times -1 plus y is equal to 4. So that's positive 36. Why I put a -1, it should be -6, sorry. It's going to be positive 36 plus -36 plus y is equal to 4. And so you have your y value being equal to 4. So my x value, I have my y value, and so your answer is -6. All right. So let me put this into the graphing calculator so you guys can see. This is x squared plus 6x plus y equals 4. The other one is x squared plus 28x plus y plus 128 is equal to 0. Oh, jeez. Can't put a 22 there if it's a 2. Just like advice. Okay. And what you see is my intersection, and there it is. A single intersection of -6. Okay. We're going to just do the other two using Desmos just for time. So number 16, you have y is equal to -x squared minus 9x minus 14, and your second equation is y is equal to -3x squared minus 27x minus 30. Let me zoom out a little bit, and you can see your points of intersection are at -8, -6, and -1. So. Last but not least, actually, of something of a problem for you to go through. This one y is equal to, so now we're looking at number 17. It's negative x squared plus 4x. So plus 4x minus y minus 1 is equal to 0. And my next one is x squared minus 8x minus y plus 19 is equal to 0. And I look at this right here, and I can already see that these two right here, they don't intersect, so this is one of those problems where the answer is no solution. So this one right here would be no real solution. All I'm asking for is real, imaginary, or if they intersect, that's what we're going to be looking at. So the last two here are on the work figure below, draw a nonlinear system of equations. Solutions are, okay, so 2, 1. The first thing I'm going to do is I'm going to actually graph my points. Let's see if I can be accurate. And negative 2, 2. Okay, so I have these 2 points right here. So I know that I have 2 graphs. They're not linear. So one, it could be a quadratic and a quadratic. It could be quadratic and a line. And I know that they intersect at those points. So I know that my one graph, so I'm going to make sure, I'm going to make this one a parabola, goes through those points, and then so it goes through these points right here. So there you go. You can have a lot of different answers. Then we have negative 3, negative 2. Okay, and so we have to draw 2 graphs that intersect there. You could have something like maybe a quadratic system, so you have this guy, and then we can have another one right here that kind of just intersects right there. Okay, and so there you go. So those are just graph a point first, and then